receiver, application, and categories. But we have even this information, all this information, into the historical part of ntopng. If you remember, in the last session, in the third session, sorry, I told you that the historical information, so the charts and so on, are all available whenever you click this chart icon. For instance, here I'm in the interface page and I have an historical chart, a chart icon. Then we have here the same icon. Whenever you click this icon, you are going to jump to the historical part of ntopng. And as you can see, here we are in the historical part. Now, I'm currently showing you the development version because we reworked all the graphic here. The stable version instead has a pretty outdated interface, and we are going to release a new stable version soon with this all this information and this interface. So I want to show you directly this interface. Now, like I was saying, here you can see the top information. For instance, here in the top, in the interface data, in the interface historical part, we have, for instance, the top application. So you can see that in the last 30 minutes, we did these applications here, the traffic using by these applications. Like we saw before, most of them were stone traffic. Like here, you have the top information even in the hosts and other historical data. You are going to have top aggregation. And in the last, in future version of ntopng, we are planning on releasing even the top categories, top senders, and top receivers in this page. In this way, you are able to understand. Okay, for instance, I want to see this traffic, this spike of traffic, and I want to analyze who did it by using which application or category, if you even define your own blacklist categories, like Alfredo told you in the third lesson. You are able to see from here who did the most traffic and with application on or with category. Now, as you probably understood, top networkers have some limitation. First of all, it is the number of elements, because like I said, all these data are aggregated. So, let's say mice is here, we never show up, so you are not able to tell, okay, in this exact second, what happened. This is a limitation of the top talkers. Another limitation of the top talkers is that we aggregate this data to reduce the amount of data. For this reason, all these information are pretty much approximation and could be lower or higher than the actual values. Not by much, but all these are approximations. So to have instead the exact values of flows, traffic, etc., you need instead the time series. So let's jump back again to the ntopng. So this here, this chart instead is not an approximation. This is a chart done by a per second basis regarding the interface traffic. Otherwise, we need the databases, like I said, ClickHouse or Elasticsearch, to take a look at exactly values contained in the flows. However, it is possible in ntopng to control this approximation. And by controlling approximations, obviously, we have even downsides. We can say, okay, I want accurate data. And if you want them, you can change the preferences directly here. From here, let's jump back to ntopng. From the settings to the preferences. If we jump to the time series, no, it should be, okay, top K heuristic. Here we have top K heuristic. By changing this button, by changing this preference, this setting, you are able to say, okay, I want top talkers more with more accurate data, otherwise with less accurate data, otherwise with aggressive data. The more accurate ones are the ones that occupy the most space, the most disk. However, they are even the more accurate. Then we have the less accurate, more approximated data, however, occupy less space. And lastly, we have the aggressive one with the lowest amount of disk used, however, with the most with the less accurate data. Otherwise, if you are not interested in the top talkers, you can even disable this information. After changing the settings, just type on save and you are done. Now, let's jump back instead to the historical part. All this data we have in ntopng are used to create charts. And in this way, users are able to understand what happened in a specific period of time. Like I said before, who did the most traffic and with which application, just to understand if there was a problem, probably in a spike in a network, or not, or if everything was right. So let's jump to the historical part, and to jump to it, we can access from the interface, for instance. Like I said before, to the historical icon, click on the historical icon, and we are back to the historical part. In this way, in this page, sorry, you are able to see all the time series we store in ntopng, all the data we store in ntopng. By clicking this drop down where traffic characteristics is written, you can access to all the available time series we have in ntopng. We have, first of all, a time series regarding information about, in this case, the interface. So in an interface, we have the number of active devices, the number of active hosts, and other information to understand the state of the state of an interface. Alerts, so if we want to take a look at the amount of alerts, and even other TCP information or score information. Then we have, if enabled, even the applications time series. So for instance, I want to see in the last 30 minutes from this interface the amount of DNS traffic. Just click on DNS, and here you have the chart with the DNS traffic, with a brief summary in this table here, where you can see the interface, DNS, and byte per second, so the metric. And we have the average, the 95th percentile, max, min, and total amount of traffic. Other than the applications, we have even categories time series. So for instance, I want to see the amount of chat traffic that was done by this interface in the last 30 minutes. We click on chat and here you have its chart. Then lastly, we have the amount of ICMP or TCP or UDP or other protocols, IP protocols. Now, before jumping to the explanation of time series, I want to show you briefly what users are able to do with this last version of ntopng historical data. In the last period of time, we developed all the historical chart pages in order to ease, let's say, the life of users. Many times, a lot of users asked for comparison between charts and so on. And so we decided to add them. And for instance, just to show you an example, let's jump back to the traffic characteristics. Okay, here we have the traffic of this interface. Now we click on the Manage Time Series, and here we have a small modal dialog where you can add information to this time series. So for instance, I want to see the average for both sent and received traffic. And here you have the average, as you can see. But other than that, I want to add another time series because I was analyzing, for instance, I'm currently analyzing, for instance, the traffic of this interface. And I want to know the amount instead of DNS traffic in comparison with the total traffic time series. So we click on DNS and click add. And here you can see a line, this orange one, with the amount of traffic done by DNS application. Now, probably from here, we are not able to understand really well, for example, the amount of traffic done. Okay, I want to show it, want to divide those two time series, and let's put one chart per metric, for instance. And here you have two different time series charts alienated by time. So as you can see, if I'm here, you can see even here the same exact amount of DNS traffic in order to analyze all this information together. And here you have the updated, obviously, table showing you a little summary of the traffic. And now let's say, okay, I'm interested in these charts, but however, I usually check those two charts. So I want to save them. To do that, we just need to click in this icon here. And this strange model, let's say, pop up. And from here, if you name it, for instance, test, you can add a snapshot. And whenever you jump back to this page, you can just click on Manage Snapshot, jump from the Add Snapshot entry to the Manage Snapshot, and choose, for instance, this snapshot we took. In that way, you are going to re-add again all the charts with the exact settings we put before. So the traffic of this interface and the DNS chart, one per metric, with one chart per metric. And you can both decide to apply the same exact current time interval. Otherwise, you can choose the time interval. To change the time interval, we have both here. You can both click on these two, and for instance, let's put from the November 22, apply. And here we have the refreshed charts. Otherwise, we can even change the time frame by using these presets, like last week or last day, etc. And just one last thing, these new charts are available for pretty much all the pages. So if we jump into the host page, let's take a look at my computer. Let's jump still to the historical part with the chart icon. Here you have the same exact charts, however, with the traffic of this host. And here too, you can add new time series to do a brief comparison. So let's say for this host, I want to see instead the HTTP traffic.
Sorry,
And here
Matteo,
you have.
there is a question in the chat. So
Mhm.
Marco is saying the snapshot is not a snapshot of the data, but the snapshot of the settings of the charts.
Exactly. Yeah.
So
Yeah.
you use
Yeah.
those settings to retrieve the data with the same characteristics. So yeah, please.
Yeah. It is just a snapshot of the settings of the chart. However, all these information are historical data. So, like I've shown you, let's jump to the interface. Manage snapshot. Here, you can both choose to to re-add the information we took the snapshot for. So, apply snapshot. And as you can see, in the exact period of time we have with the exact time series. Otherwise, you can choose to instead um, to apply the current time interval or the time interval we saved with the snapshot. So
the effect is the same as snapshotting the data because you
exactly,
get the same data with the same time frame. So yeah.
yeah. And all this information are available, like I was saying, for hosts, for MAC addresses, for networks, and so on. However, not all this information are, let's say, available by default, because all this information, all these time series are going to take a lot of disks. So we decided just to add by default the interface time series and the host time series. To add new information, new time series, let's say, to the available time series, you have to jump from the settings to the preferences. And from here, jump to the time series menu. And here you have all the settings regarding time series. For instance, in the interfaces time series, we had both the application and category time series. By default, this is set to none. Instead, I was interested in both the application and category um, time series. I choose the both option. Then, regarding local hosts time series, you can choose between off, so no time series, right, just the most important one. So, for example, the the traffic, the score, the alerts, and so on, or full time series, so many other time series with the choice of applications time series, application, category, or both of them, just like for the interface. And then from here, you can see all these are enabled. You can enable or disable the time series for various information. So, probes if you are capturing traffic from if you are yeah if you are capturing traffic from ZDMQ, so and probe, host pools time series, begins time series, autonomous systems, etc. Now let's jump back to the slides. uh, Time series are generated periodically. So for example, every second we update the interface time series, the interface traffic time series. Uh, and instead, every 5 minutes, for example, we update the autonomous system time series. So every time series has a different granularities that could be a second, a minute, or 5 minute granularities. Like I was saying, interfaces time series are written every seconds. Instead, basic time series, so autonomous system, local networks, hosts, etc., are written every minute. Instead, detailed time series, so the applications, categories, and so on, are all written every 5 minutes. This is in order to lessen the amount of data in the disk. Regarding time series storage, all these data are stored in two different um, storages. That could be one is RRD and the other one is influx database. Obviously, you choose between one of the two, not both of them. By default, we store this time series into RRD. Because RRD take a lot less space, memory, and even resources, so like CPU, etc. Because RRD time series are particular time series, stands for round robin database, RRD, and this means that whenever we create a new time series, RRT is going to create a new file with the amount of data we told him to store. So if we decided to store just 1 year of data, RRT is going to create a file with 1 year of data, with 1 year of empty data, obviously. However, RRD files cannot be changed. So whenever we decide to create a file, we cannot modify it in later times. And this is, in fact, a fixed site file. For this reason, however, RRT has got better performances and less space used. Instead, InfluxDB is a lot more recommended if you have a higher number of time series. Otherwise, if you have local disks go or with space, because by using InfluxDB you can even store this information in a remote server, because writes are performed on the over the network. So you can place InfluxDB in a remote server and ntopng in another server and then send all this information from ntopng to InfluxDB. How to change, however, this configuration? We just have to jump still to the settings preferences, time series entry, and here in the first one, in the first entry, you can find the time series driver. And from here, you can switch between RRD and InfluxDB. Currently, we support just the InfluxDB version 1.1 because the version 2 has had some bugs and so on, so we decided to not support until now. And from here, you can switch between RRT and InfluxDB. By using RRT, you just do not need to configure anything. Instead, by using InfluxDB, you have to add the InfluxDB URL, Influx database name, if you have the authentication, and the time series resolution, because um, having the possibility that this InfluxDB is in a remote location, we cannot send a per second, for example, time series, because we are going to fill the network and probably drop some data. So we decided to choose two different time series resolution for InfluxDB and send all this data together. In this way, you are able to choose between a 1 minute time series and 5 minute time series. So every minute data are sent to the remote Influx database instead of 5 minutes, for example. All this information are even accessible by using our API. Our API is available in our ntopng guide, and it is easy to integrate with other products. Just give me a second, I'm going to send you the API guide, API documentation. Um, Here you have all the API documentation of ntopng. Pretty much all ntopng information, or the information shown on the interface, are it's possible to take them by using APIs in order to integrate, like I was saying, ntopng with other application. Now, the time series limitation. Obviously, this time series has some limitation, because if we want to take a look at, for example, 1 month of data, this data has a smaller resolution because we have to aggregate a lot of points. It's true that we have a per minute, per 5 minutes, or per second storing into the database. However, if we take a look at directly 1 month data, for example, let's jump to the interfaces data. Here we can see in the last 30 minutes exactly the data we had in the last 30 minutes. Instead, if we put the 1 month, as you can see, yeah, we can see pretty much all the information. However, not exactly like just in the last 30 minutes. And another limitation by using RRD is that if you have a lot of time series, we have even a lot of files, because every file is just one time series. Like I was saying, even alerts are historical data, and by default we store these alerts into the SQLite database. And in this way you are able, and in ntopng, if you remember, we are able even to export these alerts into a remote location by using endpoints and recycling. Sometimes happens, however, that due to the amount of alerts generated by ntopng, SQLite may be slow and it starts dropping alerts. And a new notice alert drop the message is going to pop up into the ntopng interface. And to mitigate this problem, we have different ways. The first of all is to remove the some checks. So we jump to the behavioral checks, and we, for example, we disable these the alerts we are not interested in. Otherwise, another way to do that, to reduce the amount of dropped data, is by changing the settings of the alerts shown in the alerts dashboard. To do that, we have to jump from the interfaces drop down to the system one, and then we have to jump to the notification and recipient. This is the built-in recipient that store these alerts into um, SQLite. So to reduce the amount of alerts triggered, for instance, just change, for example, the minimum severity. So I just want from warning error on, from warning alerts on, or just the active monitoring alerts, etc. This way, you reduce the amount of alerts stored into SQLite and reduce the amount of dropped traffic. Regarding instead historical flows, like I said, we can store these flows into different databases. First of all, we have MySQL. However, it's deprecated and we do not suggest to use it because we are planning on removing the support to MySQL due to the amount of resources used by this database. Then we have the Elasticsearch database, so we can dump all these flows into Elasticsearch, syslog, or ClickHouse, and we highly suggest on ClickHouse. One important thing is that you can, yes, you can dump these flows to these different databases. However, we just have the UI, the user interface, just for ClickHouse. Um, MySQL, ClickHouse, and Elasticsearch are all DBMS databases. Instead, syslog are storage handled by syslog itself. Now let's take a look at how to dump historical flows. I'm going to show you the documentation because I cannot share the the terminal. Otherwise, I was going to show you the terminal, but it's not give that possibility. And let's jump to the command line option entry. And from the documentation, let's click on command line options. And here you have all the options with which you can start ntopng. And if you search for -f option, dump rows, here we have the option. --dump rows option, otherwise just -f. And then you add the format. For example, for Elasticsearch, this is the format. Here you have an example. You have the driver, let's say, the storage. Yes, stands for Elasticsearch. Then the mapping type and other information used by Elasticsearch, the URL of Elasticsearch, etc. Instead, for ClickHouse, you can add, this is the format, so ClickHouse. Then we have the host and port, and the database name and the username and password of the database. So you just need to add the -f and then this entry to start ntopng with ClickHouse. If you have the default options, so if you are running QuickHouse into your local machine by using the database name ntopng, by using username, the default username and password, you can just run QuickHouse by adding the option -f QuickHouse. Give me a second. I'm going to send you this is, for instance, an example of the chef option that you can put if you run QuickHouse into your local machine with the default settings. Otherwise, you can add, for instance, uh, these options. This is the format instead if you use a QuickHouse on a remote machine, because you can even put QuickHouse into a remote machine, or with not default username and password. After adding this option to ntopng configuration file and restarting ntopng, a new entry is going to pop up into the flows navigation bar. In fact, if you take a look at flows, we just do not have live flows, but we have even historical. And if you click into historical, here you are in the ntopng historical part, where you are able to take a look at the historical data uh, stored into QuickHouse. So all these flows are expired flows, so no more active flows that after expiring are stored into QuickHouse. And just like for the time series, for the hours, first of all, you are able to navigate um, into different period of time. So, for example, I want to see from the 22nd November until today. Let's apply, and here you can see all the data. The amount, for example, of flows stored. So here we have, for instance, 17,000 flows. And from here, you can see all the flows with different information. Like for the hours, you are able to personalize this table by adding information you are interested in. For example, I'm interested in the server autonomous system, the network, and country, for example, if available, and I'm interested in this information. So now you have all the information, and if you click here, you can see, for example, the client network, the server network, etc. And whenever you find something interesting or you want to remove something uninteresting, you just need to add a new filter. So, for instance, I want to see all the traffic done by my computer. If we click here into my computer name, you can see this window is going to pop up with client name filter and equal to this uh, host name. So if we click apply, we have all the information filtered by my client, by my computer has client name. I'm not interested, for example, in this server IP, so I change it from equal to different. And here you can see other information, for example. Then you can change the pages by clicking the different pages, and you can even filter out by, for example, protocol. Let's see if there are uh, flows with non-UDP protocol, and here you have, for example, IPv6 ICMP protocol. After doing that and finding, for example, some flow you may be interested in, you just need to click into this action column and then click info. By clicking here, you are all the information about these flows stored into the database are shown. For example, the ICMP code and ICMP type, because this is an ICMP flow, with the client server, if it is local or not, MAC address, etc. Instead, if you are interested in, for example, the alert of a particular flow, you can even click here and jump and click flow alerts. And from here, you are going to jump to the exact alerts triggered in that period of time. And in fact, as you can see, with all the applied filters, and as you can see, we have the alert triggered, so we know that that flows has a unidirectional traffic alert triggered. Let's jump back to historical flows, and other than all this information you can possibly catch by using ntopng, um, even other information are available. For example, if you click into these drop-down flows, now you are not probably able to see the drop-down, but we have aggregated queries. For example, top alerted domain. We know that this is one of the most alerted domain. So you are able to see a lot of 9.2k, 9.2 thousand alerts flows with an alert, at least an alert, in the last week, uh, with this host as a client or a server. Otherwise, we have, for example, top contacts, application contacts. So we know that the most traffic, the most flows were done by this computer, this host, towards this other host by using UDP protocol. Or top servers, uh, top sites, etc. These are just, let's say, aggregated information that you can extract still from all this information here. Another way, however, to see the data in this page is by jumping to the analysis page, because here you have the basic, let's say, flow page, where you find all the data shown in a table. Instead, here you have all the data shown with charts, etc. So if you want to analyze a problem, a network, etc., usually users start from this page by taking a look at the macro, let's say, and then jump by adding filters. For example, if I click here, a new filter with my computer is going to be added. Um, let's add even Microsoft application. And for example, we see, as you can see, we have all the filters added, and we can see that one of the two hosts was here in Italy. And the most amount of alerts was done by low output ratio. But we have even TCP packets issues, another alert. So probably from here, I'm interested in these TCP packets issues. To do that, we just need to jump to the flows and the filters remain. And as you can see, for instance, we see all the flows, the exact flows. This is the one with TCP packets issues. And we drill down directly into this flow and analyze what was missing and which was the problem. So in the analysis page, we can say that we have aggregated information. Um, both, for example, here we have different entries. Here, all these charts are for alerted flows, as you can see from here, alerted flows. But we have even other aggregated information like the applications information. So you can see from here that the most traffic was done by using VPN category traffic. And in this case, wildcard traffic. You can see, for instance, the flow count of the various application and the size of the flows and other information. Then we have other aggregated information like the score page with information regarding score, sites page. Then we have the autonomous system page, for example, if you're interested in the autonomous system. And here we can see that, for example, the most with the most autonomous system with traffic was is hosts with no autonomous systems or Google autonomous system or Digicon Corp autonomous system. One important thing about ClickHouse is that if you're able to see these entry flows historicals, it means that ClickHouse is currently configured and everything is running smoothly. If you do not see the historical entry, it means that probably um, in ClickHouse and ntopng is not running with ClickHouse. So always check this information to see if there was probably misconfiguration or a problem from ntopng itself. The real question is why we decided to use ClickHouse. We decided to use ClickHouse here because ClickHouse has really great performances and maintainability. Other than that, it is an SQL compatible database. So it means that we can do queries just like for a simple SQL database. And then it's scalable both horizontally and vertically. Regarding performances, we can take a look even at my computer, at my ClickHouse. For example, if I take, try, oh sorry, let's try to stress the database by adding last year data. And the last year data query was performed in 1.01 seconds with an amount of data of 650,000 of data. And even with if we apply filters, for instance, even string filters, so pretty interesting filter, you can see that the query speed is really high. We already took a look at these pages. One information I totally forgot about is that with these interfaces, these pages are available just from the enterprise M version on, so M and L version. Like I was saying, from here probably you are able to see the drop down I was talking about. By clicking here, you are able to see aggregated information we show, like we have seen at the top, like 7 contacts, top servers, services, etc. Now, by talking about databases, we can even change the retention of databases by jumping to the settings, preferences, and from here we jump to flow dump settings, mm, data retention here, sorry. Data retention, and you are able to change the retention of the databases. You have two entries. The first one is regarding um, flows. So ClickHouse, Influx, ClickHouse, Elasticsearch, etc. The second one instead is for top talkers and historical data. So InfluxDB, top talkers are just SQLite information, etc. Before ending, yeah, I want to show you a couple of maps, the analysis maps that we developed mainly in the last two version, and we probably got to the end of them in the last version. And these maps are the service map, periodicity map, and asset map. All these maps are regarding both historical and real-time data. Now, let's start by talking about the service map. We use service map for different things. First of all, what can you see in this map? You can see local hosts, because like it's written here, hosts with green circle are locals, so all these hosts are local hosts. Then we have multicast host with the blue one, or broadcast hosts with this other blue one. From here, you are able to see all the flows flowing through your local networks. So you can see all the communication between local hosts. We think that these maps are really interesting because it shows you really important information. The service map was developed mainly to avoid lateral movements, because if you know what lateral movements are, they are done mm, just between local hosts. And from here, you are able to understand if there was some host that should not talk with another host, however talking with it, and with some protocol unwanted. Here you see, for example, the larger version of the map, but if we jump to the service table, we are able to see the information with the hosts, total edges, rank, and the incoming edges and outgoing edges. Other than that, if you pass between the arcs, let's say, you are able to see even the protocols, and the importance of the service map is that it is possible even to add, let's say, a learning period, and decide that, for example, all the hosts scene and communication scene between two hosts during the learning period is okay, so allowed. The other flows and communications seen after the learning period are instead denied or undecided. If denied, a new alert is going to be triggered and sent to the alerts page. To change the learning period and so on, you just need to jump to the preferences, jump to the behavioral analysis, and change service status during learning and service status post-learning. So during learning, let's say that all the hosts are allowed. After learning, instead, let's put as denied. And from now on, whenever a new flow or communication show up in the service map, a new alert is going to be triggered, and a red, let's say, arrow is going to be put on the communication. Then we have the periodicity map, and a map really important to understand if there is some periodic, unwanted periodic activity between local and remote host or local or between local hosts. This is really interesting instead for botnets or attacks done in that way. So where a client and the server needs a constant check, let's say, in that way, in that case, in the periodicity map, you should be able to see all these periodic flow and see if there was some unwanted flows or not. Still, just like in the service map, you have the table view with all the information, port, observation, frequency, another important information about periodic flows, etc. Lastly, we have the asset map instead done to understand if which are your the server in your network. For example, in this case, NTP server, IMAP server, if you have, or DNS server. Otherwise, you have even POP or SMTP. I have one SMTP, but no POP services. So in that way, you are able to understand which are your DNS and local server, let's say, because many times in large networks, um, probably due to some misconfiguration or even some attacks, you have mm, DNS servers or NTP servers that you should not have. And by using this map, you are able to understand all the servers you have in your network. And still, just like for the other maps, you have the table format with the table view. Um, regarding historical data, one last thing is that you have even historical data for active monitoring, because like I told you in the third lesson, we have active monitoring data. We have the possibility to do some active monitoring towards hosts by using continuous ICMP, HTTP, ICMP, speed test, or throughput um, towards specific hosts that you are able to configure. For example, let's put ICMP towards speedtest.net. You are able to choose the threshold. So let's say that every minute we have an ICMP ping towards speedtest.net, and if the measurement is higher than 99 milliseconds, a new alert is going to be triggered. Here you can see, for example, some tests I was doing towards my local host. And as you can see, for instance, here we have a 0 megabit um, per second measurement. In fact, a red icon is shown, And probably we have an alert the page with the active monitoring. Yes, and as you can see, for example, we have the measurement failure. This is pretty much everything for the fifth lesson and the historical part lesson. Do you have any question? Okay, great. So I think, Alfredo, we can end the training here. If yeah, sure. If you want, you okay? Mhm. Send me this information towards my email, and we can write directly there. So this is my email. Just a second. And I answer you there. Probably you have some other information that you do not want to show to others. Yeah, sure, sure. Send us email if you have some questions regarding ntopng or ntop in general. No, you're welcome. Mm, if we are done, Alfredo, we can. I think we can stop the registration and the recording. Sorry, and the training here. Thanks everyone for attending the training. And if you have any question, just like I told you before, just send us an email. Bye bye, everyone.